All right, Paul, you can begin.
So yes, the contribution from me is this paper coming up to the Victorian Physics Teachers Group. We'll be meeting early December in a pub, have a beer and a meal and talk physics. And the topic is space weather, where I'm going to go into the physics of what the sun is throwing at us and the potential consequences of that. And I'm hoping to scare a few physics teachers along the way because it can be very scary. We missed last year, I think it was last year, a massive emission from the sun. It came very close to the Earth's orbit, the right time or the wrong time. Just missed us. That would have been quite significant, I think, if that had actually hit us. The implications are electromagnetic radiation, particularly X-rays, which don't normally penetrate, but in these big events, it can disrupt the magnetosphere and then the ionosphere, and then you're really in trouble. The disruption of the magnetosphere can then induce currents in the power transmission lines that can take out transformers and various other things. And then the particle radiation can then disrupt the ionosphere, therefore communication, and also satellites. Satellites, of course, above the atmosphere, so they're very vulnerable. It can disrupt their operation, and it can also destroy circuitry. And it's interesting, a paper came up, which was in Nature very recently, where they take data from Android phones. I think it's Android because Apple doesn't allow data collection. But the Androids have two GPS receivers in them, and they're able to correlate the signals from the two receivers. And from that, they can deduce what the ionosphere is doing. And because there are millions and millions of these receivers around the world, they're mapping changes, magnetosphere changes or magnetic field changes on a very large scale, much larger than they can with their fixed monitoring stations. So that's in Nature, worth having a look. You could probably just Google Android GPS Nature publication or something. And really quite interesting to see what is happening with our magnetic field and what could happen if we were in the wrong place at the wrong time. But yeah, as I said, they'll get the PowerPoint for that finalized, and then we'll find somewhere to post it so that I can share it. People can make their contribution as such. All right, so that's what I'm doing at the moment. That's keeping me busy. As I said earlier, I'm hoping to give up work next year. And so far, for the first half of the year, I've been successful in that. I don't know what else is going to come up. So I'll have a bit more time to various activities, including radio astronomy. So wait and see. And on my screen, Phil, you are the next person in line. What's happening out at Heathcliff?
So there seems to be a little bit of light at the end of the tunnel with our repair of our dish. I'll share some photos with you. If I can find the share, there it is. This one. Yeah. Yep, got it. Okay. The dish here failed nearly 2 years ago now, where the altitude worm drive, the actual phosphor-bronze screw that lifts up the lead screw and lowers it to tilt the dish up and down. The phosphor-bronze is a sacrificial part, and it wore through, but it wore through a bit quicker than it should have. So we've had to replace it. And at the same time, we decided to upgrade the radio receiver and all the electronics. The motor system is now up and running. We've got that working. And this photo is of myself and Stephen Bentley working on the focal point, trying to put in the new radio equipment, which is this sort of stuff here. So that's the front end, or that steps down from the 1.4 gig down to 70 megahertz. And this part here, you can see we've installed the low noise amplifier. And then on the side up here, all this equipment is things for controlling temperature. We've got some Peltier cells on the system to try and cool it down, which is what this black thing is here. There's a Peltier cell in between the heatsink. There's a fan at the back. So all this stuff we've only just put in last weekend, and that to me is a real sign that we're getting closer to getting all this stuff going. There's a cooling system there. That's the front end, so the antenna comes in here. That's the low noise amplifier being cooled inside this chamber. One of the other things that's interesting that I think some of you people might be interested in, we're using a special paint to go on the outside of the box. So all the surrounding box that goes around this receiver, we're putting a paint on it called Insultech. So if you want to write that down, I suggest you try it if you can get hold of it. The box itself is white, painted white, yet when you put your hand on it, it's quite warm in the sun. Put the Insultech paint over this stuff and it'll drop at 15 degrees. It's really strange. It's really good stuff. We're using that now. I don't know if you can see way up the back here, there's a little pad. That pad is bitumen like this with the Insultech paint over the top of it. And then there's another layer over the top for people to walk on it. And that's where they put their telescopes. Of course, putting a visual telescope over normal bitumen like this is ridiculous because it just heats up during the day and just radiates that heat throughout the night. Putting this Insultech paint on it, it's like it's on a grass field. It's just surprising stuff. So I don't know who sells it. One of the guys in the club purchased this stuff and we all poo-pooed him and thought it was all a bit of a hoax until we used it. Put it down on your list of something to try for cooling or keeping things cool as you need boxes like cabinets cool and all that sort of stuff. Yeah. Anyway, we've got to this point where we think in another month or so, we should have the electronics working in here. And then it'll be a bit of commissioning for the new software that we're trying to use to drive all of this equipment. So hopefully in the new year, maybe by March, we'll have a full up and running system. But getting it this far is definitely shining light on the process, and we're nearly there. It's really exciting. Thank you.
Yes, getting there finally. It's been quite a long journey, Phil.
It is a long journey. The fact that we're all volunteers really does slow down the process quite a lot. It's finding a weekend when everybody can go. It's finding time even at home to do all the preparation work, all that sort of stuff. If we were paid to do it, it would have been finished like 10 months ago, even more. But because we can only make it up there once a month or so, it really does drag the project out a bit, which it's just an unfortunate thing of being a volunteer group.
So,
But
Yeah.
we,
so how long a
we-
drive is it for you to get to the site?
for me, it's about 2 hours, 2.5 hours. For others who are in the north of the city, we're in Melbourne. This is Victoria. In Melbourne, the site is due north of the city of Melbourne. So it's right in the centre of Victoria. And it's about a 2-hour drive for most people. But if you live in the north of Melbourne, you can get there in an hour and a half, maybe an hour and 20, if you're lucky. But for me, I'm in the east side. I have to go either through the city, which is just get bogged down into the traffic and wait there for almost an hour, and then come out of the city and then go for it. Or I go the country way, which is the way I prefer, and that'll take me still 2.5 hours, but at least it's a nice drive.
Yes, it's 2.5 for me from Bayside in Melbourne. And the last time I was up, it should have been 2.5 hours home, but there was work on the freeway. It took 4.5 hours. The roadworks added 2 hours to my journey, which I was not impressed by. They closed the freeway, but they didn't make any preparations for where all that traffic would go.
That's quite a drive. When you get finished, will you be able to move the dish if no one is present at the site?
True. Yes, we've got an internet connection and we are able to move it. Yes. Yeah, so it's remote driven, although I do prefer to get up there if I can and see what's going on. So this is Melbourne, and we're just north of Heathcliff where this star is. And there, I measure distance to say centre of Melbourne, 70 miles, 112 kilometres. But it's the getting through the city that's the bottleneck.
Yep.
This is the site here, and there's our dish there. So we have visual observing in this field here, photographic observing in this field here, and some domes. And then this corner is the radio astronomy area. So that's us. Hopefully in a couple of months from now, we'll be reporting that we're receiving good signals.
Very good. So Roger, you're next in line on my screen. We got anything happening?
Unfortunately, no. Probably the same as the last couple of months. It's my busy time of year, unfortunately. I missed last meeting. I had a festival thing happening here and some players. I've actually written a play, which this afternoon I'm taking to the town hall in Mudgee. So for a short play festival. So I may actually have to leave this meeting early if it goes on for a long time because I need to get there around lunchtime. But that being said, that is a busy time of year. I'm hoping as the new year comes along, I'll have a bit more time to spend on other projects like radio astronomy. I've also got a house to rebuild. So yeah, it's not going to be easy. But yeah, we're having a get together with the Astronomical Society in a couple of weeks. There's a date there. It's December. They're talking about doing a thing for the solstice, even though it's early. So hopefully we'll drum up a bit of support then and get things happening in the new year. But yeah, not much more than that, unfortunately. But I do enjoy the meetings still when I can get to them.
Yeah. I think it's worth joining us when you can, certainly.
Yeah, thanks.
For the recording, Andrew Thornett in Tasmania is an apology. Is he? I think it's busy time for everyone this time of year. And who was the other one? Duncan Campbell Wilson is also an apology. He's doing something else. So we're very thin on the ground at this end. Ted, I think that's all we've got from our end. I'm not quite where the others are. The message went out as usual. Not got a very big take up. Back to your side of things, Ted, and the reports from US.
I guess I should kick it off. Thanks for the update. This is exciting. Things are going to go on. My one question to, let's say, Philip. So once it's working, what's the first task to do then? What are you going to look at and how are you going to do it?
Yeah. Well, there is one of the chaps, actually, the chap who was helping me build. You've probably met Stephen Bentley. He's talked on this ezRA meeting quite a few times. He's trying to drive it so that we do start a survey, a map of the hydrogen line just in total power. That would be our first thing, I think. It's just first we want to test it out and see that we can map a certain small section of the sky and see that it's doing the right things, get our calibrations pretty good. And then we'll embark on doing a survey. Directly after that survey, we have communications or a desire to collaborate with the CSIRO, which is a science division in Australia with the government. The people who work at the Parkes radio dish, they've seen what we've done and they've acknowledged our efforts and they want us to collaborate with them. So they don't get to use their dish regularly because it gets booked out to people all over the world. And when they do get to do a project of their own, the first thing that they have to do is a baseline measurements and all that sort of thing. And then from those baseline measurements, they stop their use of the dish and then go through their baseline measurements and go, oh, this is what we need to do to get proper and good recordings. And then they have to book the dish again and tune everything to all their first recordings that they had and get it set up for their proper work that they want to do. They would like us to do a lot of that baseline work for them. And in return, they would help us improve our settings on our equipment, hopefully give us hints as to how to improve our own astronomy and radio equipment, all that sort of thing. So yes, there's a lot to happen in the future, but the first thing will be just use it and do some mapping of the sky and see how we go there.
That sounds exciting. I like all those ideas. How far away is Parkes antenna from you folks, from your antenna?
It's quite a
Big
distance.
Yeah. Okay.
Yeah, it's in
Big
in New South Wales, probably halfway up New South Wales.
Okay. Very good. That might be helpful or not, but it's great to have big brothers who have done the job before. So that's great.
Yeah, we're really thrilled about being able to collaborate with them, and hopefully they'll be able to help us in ways that there's things that we still don't understand, and there's some people in this group who would know all the details, and there's a lot of people in our section of the Astronomical Society of Victoria who are not radio astronomers. They want to be, and they're learning as much as they can, but there's certain things that are just above a lot of people. And hopefully the guys from Parkes will be able to explain and coerce and teach us and mold us in the right direction. And I'm looking forward to that sort of thing.
Magnificent. Yeah, that sounds neat. What is actually going to be recording data in your world?
So
Running
at the moment,
software, I guess.
yeah, the intention is, and we're working on it still, the intention is to use a software-defined radio where we've got the receivers all set to the hydrogen line. The raw data broadband will be recorded onto a hard drive and we send it up to Parkes and they'll do whatever they need to do.
That's
from
for
that.
the park stuff. Sure. Whatever they want. But for your hydrogen, you were going to start plotting the power on this guy.
Yeah. It'll be the same thing, a software-defined radio, and we'll basically put raw data, the same raw data that we would send to Parkes, record it onto a hard drive, and then process it as best we can to get the total power, and then map it from there.
That's exciting. And your internet connection to the tower itself, to the dish itself, is pretty good from wherever you are?
It is. It has had its issues because being a club of nearly 2,000 people, when there's events on or when people turn up on the weekend, everybody uses the internet. It's not dedicated to the radio astronomy people.
Sure, and there's
So
only one pipe. Yeah, okay.
That's it. Yeah. So during the week and on times when the weather's inclement, we have free reign of the internet. So there's times when they're better and times when they're not. And we have had it in the past where we used a satellite link, which was not reliable. And now we're using Elon Musk's, I always go to say Skynet, but it's Starlink, isn't it?
Yeah.
Yeah. Skynet's the Terminator. Yeah. And Starlink is a little bit flaky at times, depending on where the satellites happen to be, but it has improved over the years that we've been using it. So it's pretty good.
Excellent. For myself, then, let me go to that. I haven't been doing much radio astronomy except maybe 2 weeks ago, I was playing with plotting 3D graphs and then even 4D graphs out of the ezRA stuff. That was recorded on our Drake's Lounge from 2 weeks ago. So I'll let you go look at the video. That's what I've been busy with here. And actually, I've been playing more with Global Meteor Network, which is optically finding meteors in the sky and trying to figure out exactly where they are and where they came from. So I'm having fun with that. Paul, back to you, I think. Who's next?
I'm just trying to get my PowerPoint on space weather so that we can have a quick run through it. I'm just transferring it to the computer. It's on your side. Ted, anybody else at the USN?
Very good. I pick on Helen and then Wendy and then Richard. Helen.
Oh, you don't pick on me. I did learn something today on that Carrington event. I never heard about it and I just Googled it. So I'm going to read up on it tonight. I like learning new things.
Okay. I hope you can sleep after all that, though.
Oh, yeah.
Can I just say something about the Carrington event? When I explain the Carrington event to people, I always tell them that the internet failed when that happened. And they look at me and go, what, the internet? Hey, what are you talking about? That was in 1890 or something. I said, all the telegraph operators. So keep that in mind. The internet fails.
Thank you.
Yes, the telegraph operators got shocks from the equipment because of the induced current. And there was a lot of disruption to the what was then the internet, as you say. Point.
Excellent.
So,
Thank you, Helen.
still at your end, Ted, while I'm just getting this.
Very good. Thank you, Helen. Wendy, you were next, and then Richard, and then Tom.
I have to say, I've always avoided reading about the Carrington event because I figured, why depress yourself? Is there a book or should you just read on Wikipedia?
There are books, Helen.
Anyone in particular?
I use Kindle. I just put space weather into Amazon, into the Kindle section of Amazon. And there's a whole lot there. There's some university level textbooks that are like $60, $100, $300 if you want to put those. As far as sort of an accessible book, I haven't found one so far. I might have to write it myself.
Oh, okay. I'll read what they have on Wikipedia, then decide where I'm going to go from there.
Yeah, have a
Yeah,
look on Kindle.
I have them.
Oh.
Sometimes I look on Project Gutenberg because I've noticed that Amazon is taking books off of Project Gutenberg and putting them on Amazon and charging you for books that are essentially free. But I don't know. Like I say, I'm sure that it's interesting from the standpoint of planetary and solar flares and stuff like that. But on a personal level, I'm really trying to do things to cheer myself up rather than like not watching horror films and things like that. And of course, I have to set up my solar cooker, but now I have that invaluable knowledge that you have to take it out of the box. So that's really, and this time of year, there's a lot of other stuff going on. I don't know. I figured 20 minutes a day in radio astronomy, I can do that. And that's all.
Yes, I'm just finding a website for you, Helen. Just keep talking amongst yourselves and going around the screen, and I'll find it in a moment. Really there.
What about your other thing? Is it ready to go?
Almost. I'm just transferring it.
Very good.
Really there.
Okay. Time for Richard. Richard, what's been going on? What are you busy with in Hawaii?
What am I busy with? First, I did have a question for Philip. How many folks do you have working on the dish? Yeah,
The radio astronomy section, surprisingly, or not so surprisingly, is made up of very few people in the club. There's 2,000 people in the club, and there's 12 people who are into the radio astronomy. Very niche sort of section. There's other people interested in radio astronomy, but they're waiting for it to be working before they start to show their interest, if that makes sense. There's a few people like that. But yeah, there's about probably 8 of us that are actively working on the dish and doing things. And then there's the other 4 or so who drop by every now and then. But yeah, not so many in the way of a group. If there were more, I'm not sure if it'd make it any faster.
Yeah, I understand. I really enjoy seeing the picture of the dish there. I was fortunate enough to have an identical instrument at the University of Florida many years ago. And so it brings back some good memories. That one was used primarily for looking for very short solar burst activity.
Okay.
And we also did a little bit of satellite tracking with it too. Listening to some of the Soviet lunar probes and so forth. And I was away from the university and then came back to visit and went out to see the dish, and it had been stolen.
Yeah. Something of that size.
Something of that size. So there's some ham somewhere in Florida who's got a hell of an antenna in his backyard. It was quite a shock. So anyway, do you guys, how do you fund the operation on the dish? I know it's not inexpensive.
True. It's pretty much self-funded by the club and a lot of volunteer work left, right and center. And the dish itself, when we purchased it, and that was just the struts and the aluminium dish, that was like 3,000 Australian dollars, which is reasonably good.
Yep.
Overall, I think it cost us 120,000 Australian dollars to build. And to be honest, we got away with that's really good. Yeah, we were very lucky to be able to achieve what we've achieved. And it's a little bit of beg, borrow and steal here and there, but most of it's just been volunteer work and effort to get it to that point. And yeah, you're right. It's not a cheap undertaking, that's for sure.
Do you guys have a place to sleep overnight there?
Yeah. Yeah, there's dormitories, I suppose you could call them, where there's 8 rooms, and each room has 4 beds in them, a two bunk beds type of thing.
Mhm.
So, yeah, it's very well set up, the whole site. The facilities are all there for everybody. It's quite a setup. It's been really good. That's only happened over the last 10 years or so, from where it used to be like a tin shed, like a car garage tin shed where everybody just lived in that, to now having the tin shed is now the club room and it's been decked out inside properly, and there's toilets that are proper toilets, and there's the accommodation room and all that sort of stuff. The amenities are really quite good now.
Sounds like a great
In
setup.
what
there.
year? In what year was that dish first assembled? When was it upright?
2016, I think it was. I think it was 2016. I'd have to look back on
Put
the.
up on 8 years at this point. Very good.
Thanks, Phil. It's nice to learn a little bit more about the dish and the people and the facilities.
Yeah.
I
Um,
hope we
You're
could.
welcome.
I hope we could hear from Tom and then Andy. Tom, you there?
Yeah, I'm here, but I really don't have anything to report. I've been doing software development on old packages from the aughts to the 18. This is the first time I've had to open it up since 2018, and it's not going quickly, so it's keeping me busy. Other than that, I've been trying to keep up with the traffic for ezRA, and I'm still quite a bit behind. There's quite a few purchases from the store and elsewhere that I need to process, but I'm working on it as fast as I can. And if people have questions, I'll try to answer questions.
Thank you, Tom, for all your treasury duties. Andy, are you still there? It's late in your world.
Yeah, I'm still here. I can't seem to turn my video back on because it says my host has stopped it. Are you able to turn it on?
Try to push buttons, but go ahead. Tell us what you've been up to.
I was going to just show a few slides if I can get the video back on. Or I can share my screen or whatever. I don't know if I can share my screen anyway.
Try sharing it, and I think that should work.
Probably will work. Yeah, you don't particularly want to look at my face anyway, so. Can you see this presentation?
Yeah, it's there.
Yeah, right. Okay, great. So you can see it says Litchfield Radio Observatory. Yeah. I thought, just to say for Wen's point of view, sorry for benefit, we were I was pulling her leg a little bit earlier on, but I don't want her to go away from what I'm going to say next and get any impression that I know what I'm talking about. I'm sure she knows a lot more than I do, but I do some various astronomy talks around the UK, and so I've had a bit of a chance to pull things together and make them look quite good. There's opportunity to pick some slides from this to just show you what I'm doing. The other thing is just to say that who was talking about their group? So was it Philip? I can't remember. He was talking about their dish and the 4,000 of their group. If after you see this, you think you would like me to present a little bit of a presentation to some of your members, then I'd be more than happy to do so online. At the moment, doing a series of 8 talks for a group in Penang in Malaysia, which are going down quite well. So anyway, you can come back to that. So my major interest over the last year in radio astronomy has been indeed what you're talking about in terms of mapping the Milky Way. And I've a bit of a protege of Ted's here, who's been very much a mentor in this whole process. And without him, I would never have achieved anything. So this is my backyard, and this is where this all occurs. And I've decided to go over the top and call it Litchfield Radio Observatory, which is obviously way more than it deserves. I would just say I used to, for you guys, do appreciate some of the bits you talk about, and perhaps appreciate more than some of the other people might do about the sort of distances involved for you, because I used to live and work in Whyalla in South Australia, Australian bike point. And we used to look after locations up to 1,000 kilometers apart. So it's a bit weird when you drive up the road and you pass the landing strip the roads form part of, or you, I forget where it was, used to stop and stay, and there was a sign outside that said sort of 20 odd people and 2 million flies, I think. So it's an area. But anyway, one day, hopefully I'll have a look at these things. One thing we didn't get in while was snow, I would point out. So I'm not going to show the whole this presentation clearly, but I just want to just pick 1 or 2 slides just to say where I am. So this is obviously the UK, and I'm stuck bang smack in the middle, just north of Birmingham. So we do have an awful lot of radio interference. It's just 52 and minus 1.82 on the coordinates. Blah, 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 blah. Past the rubbish. What I was particularly interested in was this type of projection of the Milky Way and trying to actually see from the outside in, as it were, a bit like you're from in the polar region, and actually see the spiral. And that's what I've been able to do. So that rubbish. It's all part of the presentation. There we go, blah, blah, blah. So this is what I use for it. My main one, which is actually an ex-military array, which works pretty well. It's 86 by 86 centimeters. And as you can see, it's a 4x4 dipole. This is called military band 3 in the UK. These things are quite rare, but we have tested it, and its performance is about the same as a 1 meter dish. So it doesn't really make much of a difference what you're using. The 1 meter dish is a 1 meter dish, or 1 meter aerial is a 1 meter aerial. And I like this very complicated joking mount, which is just a simple wooden table with using TED software there, Easy Radio Astronomy. And this allows you to just point it in one direction, and it does drift scans of the sky. So you really don't have to bother too much about trying to move anything around. And then you just change the elevation, which this complicated system of a couple of sticks at the side with a few holes in it, which allows me to change the elevation. I did, in fact, actually buy a Lazy Susan to allow myself to be able to change the orientation, but I've never had to bother to install it. So this system just seems to work incredibly well. Oh, that was me making an antenna at one point, which we'll come back to in a minute. So it's still part of the presentation. Yeah, it's simple stuff. See, these sawbirds, projectors, filters, which do a really good job, and amplifiers. And of course, the old software-defined radios, which making life so much easier and so much cheaper these days. So there's a bit of easy radio astronomy in action, collecting a bit of data there. So some data collection, and here we are. Here's my map. I've got to the Milky Way. This is on the basis of 500,000 observations, about 2,000 hours. I've had to go at trying to map out the arms a bit. Quite impressed with the amount that you're able to get. As Ted will tell us, there's a limitation with the mathematics in terms of which bits of it you can actually detect. So between 0 and 90 degrees, you do pretty well, and everything else is difficult. But nevertheless, it is quite incredible to look at that and say, gosh, I've been able to demonstrate those arms myself. And then while we're about it, we bothered to demonstrate dark matter, and then weigh the Milky Way while we're about it as well. The other thing was that was being asked about at the beginning, talking about, so just quickly see what this was, solar cooker. Somebody on the main ezRA forum was mailing this, was talking about these solar dishes, which you pick up in the US on ebay.com for $50 and a little bit of postage. In the UK, we have ebay.co.uk, and they don't sell them on there. But I did take a look, and I found somebody who was in fact selling one on a house clearance. Clearly somebody else had bought one and they're getting rid of it. Okay, it cost £50 plus a bit of postage, and voila, it turned up. This enormous device, which is me putting it together while my wife was out of the house, so she couldn't see me all over the kitchen. And here we are with it outside. You can see the normal attachment that's on there. Where's my antenna on there? But that's the normal attachment for sticking your kettle on to try and heat it up. it's not particularly sunny in the UK, not at this time of year, but I walked past it and had quite a hot patch on my leg, which I found quite concerned. So I stuck a cardboard box at the focal point and it burned a great big hole through it. So these really do collect quite a lot of energy. So you can see there, I got some cheap spray paint and I sprayed over the minor stuff that was on there to get rid of that reflective surface, which is why it looks grey rather than the original sort of reflective mirroring surface there. I've also got a few bendy bits of metal from the local hardware store. They actually come pre-bent, these pieces of metal, and I've used that to connect my antenna, which had been built for a different project, but has now been brought back into surface to use as my waveguide here. And built another one of my wooden mounts, and there it is, all mounted together, blasting away, collecting, it's what to say, star radio light, I should say. And so it's now in action, collecting data, and hopefully very soon I'll be able to show people some maps that this has been able to produce. So that's all I wanted to show you guys.
Very good. Very impressive.
Thank you. It perhaps looks more impressive than it is because I've had a chance to put the presentation together and make it look nicer over time.
Yeah, that might be a project for me for next year. If this giving up work really does work. Lots to do.
It's really not difficult. Mapping the Milky Way doesn't require really large, especially for you guys where you've actually got some nice radio quiet areas to use. And if it works here, gosh, if I can do it, anyone can do it for a variety of reasons. I'd say to people here, it costs about £200 if you're doing it from scratch. And that's assuming you buy everything over the counter and don't actually make, say, your own aerial or whatever.
Yes.
Thank you, Andy. You're trying so many fun things.
Yes.
Have you found what you wanted to present?
Yeah, I'm ready to do this. If I can do that, I should be able to share button gone. Time screen. Make this. Is that sharing properly?
We see Space Weather Prediction Center. Yep.
Yeah. So I thought, well, Helen's question was, where's the place to start? This is your own NOAA space weather website. When I go through the presentation, I'll just whiz through the presentation quickly, but there are some other ones around as well. But this gives you the current space weather conditions, and there's something happening here. R1, S2G, you need to read up what those are. But then as soon as things go away from green, you know that there is something on the horizon. NASA is announcing that the sun has reached the solar maximum, which is interesting. They don't usually say while we're still in the middle of it. Pictures of the sun, pictures where the aurora might be. So that aurora forecast is important. If you keep an eye on that, you'll see if you're further south, view that, what you might get. We've got the equivalent for the South Pole and coming further north, X-ray flux, proton flux. But then down here, all these headings here, you can click on any of those and there's an explanatory article. So geomagnetic storms, for example, you can jump in there and it'll give you the background, and it's written in a very accessible way. So I would suggest that that's probably a good place to start. Your local one, NOAA. NASA has the same thing or similar thing. Our own Bureau of Meteorology has the space weather section, and then the Met Office, Andrew in England in the UK has something similar as well. Not quite as extensive from the Met Office, but it's all there if you dig around and find enough. But the presentation is this I wish I won't go at presentation speed. I'll speed it up a bit, but I think we can go through, because basically what I'm starting out with is we've had these massive aurora coming up. People have been seeing aurora much further south in the northern hemisphere and much further north in the southern hemisphere than you would normally get. So is this significant? Yes, it is. So going back all the way to Galileo and his drawings, so he pointed his telescope at the sun. I'm still trying to pin down why he didn't blind himself. Some references say that he waited while it was misty or something like that, or he did it later in the morning when the sun was on the horizon. Other resources are saying he did a projection onto a screen, so I'm not quite sure whether it might have been some combination of that. But what's interesting is that Galileo was not the first to observe sunspots. Harriot in the UK was, they think, the first one recorded, and then China with the pseudonym Apelles and Goldsmith. So there were others looking at the sun even before Galileo did in 1612. And now we can look at the sun in real time. So if I click on the link, I should get straight through to Soho, and that's another good. It's loading Mauro. There's Soho, the Solar and Heliospheric Observatory from NASA. And you can go to the sun now, and there's the sun in real time, or very close to real time, in different frequencies. These are ultraviolet. This one's the visible light, with quite a few sunspots on at the moment. There's a magnetogram, which is very significant. That's part of the whole story of space weather. And then there are the ones where they've obscured the sun. So you're actually seeing the corona, and you see these massive emissions coming out. If they're going to the left and right and up and down, it means they're also coming towards us. So that's a very good resource to keep an eye on. Why is that not working? Where are we?
Oh, I appreciate all this. Thank you very much.
Going left, perhaps.
For some reason, it's jumped out of my
On
presentation.
the left, can you? Yeah.
I'll just go back and see if it'll get back to my presentation. Yeah, there we are. So there are various other things. This is 2 weeks in the life of the sunspot. I won't run it now, but that's on YouTube. So you can, it's another place to go. Ellen, go to YouTube, just put in space weather. And with this one, they show in here, you can see the arcs, which is the magnetic field associated with that sunspot. So the sunspots come in pairs. That's the two poles, north and south. And then these curved magnetic field lines go between them. I can't run it from here because I'm on a PDF version. But you'll find that, just put in 2 weeks in the life of a sunspot into YouTube. And then this one shows variation in sunspot number over a short time, over a period of, I think, about a week. But this is the variation in sunspot cycle going back to 1913, with now the well-defined 11-year cycle. And we are pretty much here at the peak, or they've declared the peak now of cycle 25. So that's why stuff's happening. We're on the sunspot maximum. We're not on the big ones like we got here. Whereas this is 86, I think. There's a couple of big ones here. The one we're in at the moment is a smaller one, but it's still a very active sun. That's going back even further to 1600 with data from a variety of observations. And this time, the sunspots totally disappeared for quite a significant period of time, which is really quite interesting. at the bottom of all this, no one knows why this is 11 items. Nobel Prize there if you can work it out. But the Mona minimum was a time when it stopped happening for whatever reason. So what's going on? Structure of the sun, I'll go into a little bit of detail, in more detail in the presentation. But basically the core is where the fusion is happening. And the radiative zone, the photons work their way through. Takes them anything up to a million years for a single photon to make its way out. The convection zone is very mobile, and that's what gives rise to the magnetic field. And then you get the chromosphere and the corona. So there's a three-dimensional version of the same thing with these layers. Obviously, we don't really know what's happening in there, but this is all modeling of what we think the sun is how it's structured based on evidence that we've got. And here we see the sunspots in the photosphere, a flare, and then here's the corona around the outside. So the big thing is it's an active sun. We don't think of it in those terms, but at the moment it's very active, solar maximum. So just touching briefly on prominences, flares, coronal massive ejection and the implications for us. Here are the prominences. So we tend to see them added because we can't see the ones that are coming towards us. But again, you can see the curves of the magnetic field lines as these things go out and follow field lines around. A solar flare on the limb here, if that happened to be on the main front surface and the timing was right, we would cop that. We would get the effects of that if we just happened to pass through our orbit at the same time that this was. So equivalent to billions of nuclear bombs going off all at the same time, massive amounts of energy, it's high energy radiation, predominantly X-rays and ultraviolet. Well, we know that those are the high energy ends of the spectrum. And yes, so this energy is this massive amounts of energy being thrown into space. Not only energy, we have particles. So plasma and energetic particles interacting with the modes and delivered into space as the solar wind. So we sit in the solar wind all the time, but at active times, it becomes even more significant. So we have this very simplistic view of the Earth's magnetic field. So usually drawn, this is a sort of school type diagram that we use. It's as though there's a bar magnet in the middle of the Earth, not really like that, of course, but it's the iron, molten iron moving around, giving rise to the magnetic field. But it's really more like this. It's more on the sun side, has this bow shock where the solar wind is coming in and being deflected. Good, because without this deflection, we wouldn't be here. And that's significant. Then on the away from the sun, this magneto tail goes, and they're saying that this goes all the way to Jupiter, that tail, that misshaping, the bending of the field lines of the Earth's magnetic field pushes them right out of behind on that, away from the sun side. So really, what's going on, this is obviously not to scale, but here's the active sun pushing this stuff out. And here we are being protected from most of it by the magnetosphere and then by the atmosphere. So that combination of the magnetosphere and the atmosphere protects us from the worst most of the time. Here's real weather down in the troposphere. And here is the ionosphere being up here, which is courtesy of the solar wind. So we get protection from the magnetosphere, we get protection from the atmosphere. But because the ionosphere is based there as a result of the variation of the solar wind, when the solar wind varies, the ionosphere varies as well. And that has massive implications. Consequences, the aurora, both australis for us and borealis for you, is an interaction between the solar wind and gases in the upper atmosphere. And that's a really good one for senior physics at school because we go into atomic energy levels and so on. Geomagnetic storms are a result of the bending of the Earth's magnetic field. And there's one simple example in 1989 where the power system in Quebec collapsed. And it says it left millions without electricity for hours. Yeah, all right. Go and have a look at the TV series Cobra, where it took out some transformers. Did they have spare transformers waiting? No, they didn't. They had to bring spare transformers in. This was in Britain. They had to bring transformers in from Germany, I think, which took a while. But then there's all the political the results of all this, the criticism of the government for not being ready, riots in the streets because people were without what they expect, their power and all the services and so on. So there's much more than, even once the electricity is back on again, much more a consequence of what could happen. Operation of satellite systems, so they stop working properly, or permanent damage. So although the satellite electronics in space are in a severe storm, we could have permanent damage to those systems. That can affect worldwide communication, and we're very dependent on that nowadays. And the GPS system relies on those satellites as well. That means disruption to aviation as well, radio communication, navigation, and because they're high, increased exposure to radiation, that includes the passengers. And have a think about how reliant we are on this stuff. If it gets taken out or gets disrupted, then things could get very difficult very quickly. And it's not just loss of the systems, it's the way that people respond to this, rioting in the streets and blaming one another and all sorts of things like that. It's an interesting one because the ionosphere is affected. That affects HF, worldwide communication, as we know. Airliners and ships, when they're away from land, when they're considerably away from land, they're using HF. The HF is part of the communication system. So if the HF communication system goes down, then you could be in trouble. I'm getting a message, my internet connection is unstable. Am I still going all right?
Yes, you're good enough.
Still working. Yep. This is the one about mapping the ionosphere using androids. So there's the reference Nature 635 in 2024, pages 365. So look up Nature 635 from this year, find that article. It's a really interesting one. The difference between detecting variations in the ionosphere using fixed stations versus aggregating data from millions of Android mobile phones, cell phones. And then here are the references. So our own Bureau of Military has a Space Weather Center, Space Weather Service. NOAA, the one that I've shown you. And here's the Met Office one. So just go to metoffice.gov.uk and you'll just search space weather, you'll find it. The NOAA one, and NASA has its own one as well. And they're full of really good articles, very easy to read, easy to follow because they're written for the general public. So Helen, that's some good starting points there. And then as far as our physics group is concerned, I'm going to relate it to our Victorian curriculum. It's 2.0, which has just come out, starts next year. It's very bland in the way it's presented. And so are the VCE, the Victorian Certificate of Education units. These are all areas which we can link to space weather as an example. And then that's year 11. And then this is the final year of school, year 12. So those are areas where we can get involved with this. And then I'm finishing up with this, which is turning bland statements like this into what I think is a really exciting piece of artwork. This is actually in NASA, this artwork, which shows over here the Big Bang and through to formation of planets, solar system, volcanic Earth, cooling down, formation of simple molecules through RNA, DNA, microbes. So this is the path of evolution along this line here into them crawling out onto land, flying, so a pterodactyl, up to the variety of animals here. And then right up here, there's the optical observatory and the radio observatory looking back, just and he is looking back at the Milky Way, mapping the Milky Way, hydrogen line, as we're doing ASV. And so it completes the circle. Start with the Big Bang, and you go through to intelligent life, looking back on where we came from. And NASA Exobiology has this center for of the emergence of life. Again, massive number of devices, really stuff, and worth a visit. So I think it's the quick version.
Yeah, that's a
Now,
phenomenal
that's-
bit of information. That'll
Yeah,
keep
that's been
quite a
recorded.
while.
Yeah, that's been recorded. So if you go to the recording once Ted once it goes out on YouTube, then you could actually slow the recording down and get some of the information from those slides. I just thought I'd do the quick version. The version that I do for the physics group will be about an hour
Nice.
with questions. So we'll be able to take a bit more time over it. But as I say, once Rich puts up the recording, you should be able to read my slides and get the information from them. Ton of stuff. There you are. Evan and others, there's your reading for the next few weeks.
Mhm.
Any questions, any thoughts on that?
No, thank you, Mr. Butler. I really appreciate that.
Well, it's nice being called Mr. Butler.
Thank you, Mr. Butler. It's very nice.
I am Mr. Butler. As far as my students are concerned.
Well done, Paul. That sounds good.
Okay, so Ted, that will, as I say, that will go out on the recording so people can have a look. And any questions, just send me an email or put something on the SARA list and we can keep the conversation going. Back to you, Ted.
Wow, I think we've covered everybody and so many things to go explore. Grab the chat. I suppose it'll also be available up where this YouTube gets posted as well. But you go to chat and up in the top right corner, the 3 dots, and you can save chat. That'll save you some typing. That's all. Excellent, Paul. Another good week. See you in a month.
Covered a lot of ground. Now, December, we don't usually have a break land Australia because it basically hits Christmas. For us, I think if people want to, we can still do it. People are around. We'll see what Rich says. We'll see what Rich thinks. It's certainly this time of year because it's summer for us. A lot of people go away in December, January. We'll see what happens.
Very good. To
Okay.
be determined. Thanks, everybody. See you next time.
Okay.
Thank you.
All right. Thank you. Thank you, everyone, for coming.
Thanks.
Cheers. Bye.
Yeah, so.